British Columbia, and then that will service if you know anything about the geography of the area, it's right in the middle of a very large market area with the Okanagan Valley on the east and Vancouver on the west. And then we can send production all the way up into central British Columbia, and hopefully, what I would like to do is get some production going down into Seattle and Tacoma.
What has been the response of the people you've been talking to so far?
In what regard? The buyers?
The offer that you're bringing out on SG Alberta, as far as the share purchase.
Excellent, absolutely excellent. Yeah, there's. The problem with our operation is that it takes a little bit of time to get involved with. You've got to understand the present state of the greenhouse industry, which is, well, it's hundreds of years old, but the degree of sophistication that we put into this operation, especially with the cost of energy right now, is fairly timely. It's as I said before in the opening, we're all of our production is clean insofar as that we're not experiencing we do not experience any difficulties with things like salmonella, enterococci, e-coli, and those sorts of bacteria, and some viruses, because we sterilize our water as it moves around. So we can provide people with this information, and it takes a little while for them to begin to understand what we're doing. But all of a sudden, the light bulb goes on. It's extremely well accepted.
So you sterilize your water. What is the system you use to do that?
Every time the water circulates in our operation, we send it under what I call a UV pan. It is a pan that's about 4 feet long and 2 feet wide, that has the water as it comes back from our ranges in the rotation of the water goes into this pan, and it spreads out over I guess about 1/8 of an inch, 8 to 3/16 of an inch, and then it gets irradiated with ultraviolet light. And this knocks out the DNA of the bacteria and the viruses and all the fungi that are in the water, so that they're unable to function. And this happens every hour of rotation. The other one that we're doing that I'm contemplating, but I don't think we'll have to do it, is the use of ozone in our system to oxidize the water and make sure that everything is perfectly clean. Now, these are very cost-effective ways. I mean, like a lot of things that we do in this greenhouse operation, it requires power. We need power for fans. We need power for our sterilization. We need power for water treatment. But it's generated right on site, so basically it's free. So it's a luxury that is I smile every time I think about it, because it's so if we are we got a 10 horsepower motor running, or a 5 horsepower, which we've got a couple of those. So what? We got all the electricity that we need.
In our conversation the other day with that gentleman from Ontario, he had cited 39 greenhouse operations in Ontario, and the smallest one was costing $30,000 a month in natural gas bills just for the climate control in those buildings. Can you eliminate that cost completely?
Yes. Well, the thing is, if you look at $30,000, that's in Ontario. Our winters in Alberta are a little bit more, let's say, robust than they have in Ontario. And as long as we have the availability of fuel, then there are no problems. Our buzzard will generate 8 million BTUs an hour, and this is adequate for maintaining temperatures at night to about minus 38 Fahrenheit.
Now you mentioned earlier on the water and recycling the water that ran through the ultraviolet lights. What about new water you bring in? How's that treated?
Okay, good question. That depends on where the water is coming from and the condition it's in. Now, if the water is, let's say, coming from a lagoon meaning a sewage lagoon, then what we'd have to do is take the biologicals out. So we would have sand filters and charcoal filters ahead of that water. And if there are things like chlorine and other, let's say, insecticides or pesticides, other agricultural runoff, we would take care of that. If it's ocean water, we would filter out and kill all the organisms in the seawater. And then the final treatment is reverse osmosis, which just basically eliminates all of the minerals in that water. So we have a quality of water that's next to distilled. Then after that, what we do is we add all of the nutrients, the 52 elements that are required for our crops, back into that water, and by maintaining that balance in that water, we're able to, that's what we irrigate our crops with.
So after